And coming to the filter, so generally the filter means it rejects the unwanted frequencies from the input signal and allow the desired frequency. And we know what is passband and stopband. The passband is the range of frequency of signal that are passed through the filter. And in the stopband, the range of frequency of signal that is blocked by the filter. And digital filter, we are concentrating more on the digital filter here. It processes and generate the digital data, and it consists of elements like adder, multiplier, delay unit, and it is described by the difference equation. And here the frequency response of our output can be easily changed by changing the filter coefficients. That is quite possible in this case, whereas in the case of analog filter it is not that much easy. In the case of digital filter, it is very, very easy. Simply by changing the filter coefficient, we can able to change the frequency response. And in the case of designing of digital filter, so using the analog filter specification. So analog filter in the sense we can have low pass filter, high pass filter, band pass filter, and band reject filter. Right? So all these are coming under the filter category. So here for the analog filter specification, we are given with the pass band and stop band and the lower cutoff and upper band frequency, everything we are given with, isn't it? So using the analog filter specification, the transfer function of the analog filter is designed and then transformed them into the digital filter using the suitable transformation methods. What are all the transformation methods using for the conversion from analog filter to digital filter? Here there are three famous methods: bilinear transformation method, impulse invariance method, and backward difference method. Otherwise it is called approximation of derivatives. So you should remember the transfer function of the analog filter is represented with h of s, capital h of s, whereas the transfer function of the digital filter is h of z, right? So h is the transfer function here. So h of s is the transfer function of analog filter. H of z is the transfer function of the digital filter. So a conversion from h of s to h of z is obtained with these three methods. And here we are having the impulse IIR filter and FIR filter. And in this IIR filter, infinite impulse response filter, we are having Butterworth filter, Chebyshev filter, both these categories, right? So IIR filter is recursive in nature. Recursive in the sense output depends on the present input, and past output samples. Recursive type. Feedback, it requires feedback. That is the meaning. So we are having two different filter types, Butterworth filter and Chebyshev filter under IIR category.